Hi everyone, welcome to my channel. My name is Thirumavalavan Srinivasan. In this video, I will show you how to create Amazon RDS database engine on custom VPC. Let me introduce about myself. My name is Thirumavalavan Srinivasan. I am working as a solutions architect and I have over 17 years IT industry experience. I am also an APN ambassador for Northern America region and I currently hold 8 valid AWS certifications. In this video, we are going to achieve this following architecture. So we are going to create a custom VPC and we are going to create 6 subnets in 2 availability zones, like availability zone 1 and availability zone 2. And we are having multi-layer architecture. Here in this diagram, we are having 3 layers. The first layer is web services layer that is accessible from the internet. That is public subnet. And then we are going to have private subnets for applications services. Here we are going to create EC2 instance that doesn't have access to the internet, which can only be accessed from the instances from the public subnet, from this EC2 instance to here. And next we are going to have third layer for database services. And here for database services, it's a private subnet. We will not have any access to the internet. We can access it only from the private instances on the private EC2. So for example, if the user will only be able to connect to the instance on the public subnet, that is public EC2 instance, and we will have SSH access to this instance. And once we connect to this instance, this will act as a bastion host or jump box, and from here we will be able to access the instance on the application layer. Here we are going to have another instance which doesn't have an access to the internet, only the private EC2 instances. To download the packages or to access the RPMs, this instance will have access to a NAT gateway. We'll create a NAT gateway in our public subnet, and outgoing request for the internet will go through the NAT gateway. So we cannot access this instance from the internet. And from the private EC2 instance, we will be able to access the database that we are going to create. So for this demonstration, we are going to create Amazon RDS MySQL database engine in multi-availability zone. Let's now start implementing our architecture. I have logged into AWS Management Console. Let's go to VPC. Let's open VPC in new tab. We are in VPC Management Console now, under VPC Dashboard. Let's click VPCs. We currently have one VPC, that is the default VPC. We don't have any custom VPCs created. Let's go ahead and create one. Let's name our VPC VPC1. Let's use 10.0.0/16 IPv4 shader block. Our VPC is created. Let's go ahead and create subnets for our 3 layers: web services layer, application services layer, and database services layer. Create the subnet. Let's select VPC1. Let's name our subnet and select US East 1A availability zone. And use 10.110/24 IPv4 shader block. And let's go ahead and create 5 more subnets. select yours is 1B, (2.0/24). This is the subnet for application services layer. Select US host 1A. (10.130/24). Select availability zone 2. (10.140/24). Two more subnets. This is 1A. (10.150/24). Select yours is 1B. Select 10.1.6.0/24 and go ahead and create all 6 subnets. Now if we click on the subnets and now we can see all our subnets created here. Let's go ahead and create internet gateway. Internet gateway for our VPC. Let's create it. And it's currently detached. Let's go ahead and attach it to our VPC and select our VPC. We can attach to VPC 1. We can only have one internet gateway attached to any particular VPC. Now it is attached. Let's go ahead and create the route tables. Currently the default route table created for our VPC, and it has all the subnets associated with it. We are going to create new subnet and associate new route table and associate the subnets to the route table. Create route table. Public route table. Select VPC 1. Create it. Likewise, let's go ahead and create 2 more route table for application services layer and the database services layer. Private route table 1 and VPC 1 and one more. This is for the DB layer. Now let's go ahead and update the route table. Select public route table and subnet associations. Currently we don't have any subnets associated with it. Let's edit subnet association and select the public subnets that is named as public. So both of them 10.1.20.24 and 10.1.1.0/24. Save. Now we can see the two subnets associated with this route table, and let's go ahead and edit the route. Currently by default we have 10.1.0.0/16. That's the default route. Let's add route. Select internet gateway. Any outbound traffic to the internet will go using our internet gateway. And let's go ahead to the private route table 1 subnet association. Edit the subnets. Let's select application layer subnets, the private subnets, that is 10.1.30/24 and 10.1.4.0/24. Save it. Now you can see the subnets associated here with this route table and routes. For this route table we need to create the NAT gateway and attach it. Let's do that in a while. For that, let's go to private route table and edit the subnet association. The subnets created in the private subnet 10.1.50/24 and 10.1.60/24, and currently it is associated with the main route table. And this is the route table. This is the subnets that we are going to use for our database. We are done. If you see the routes, we have only the route to the local route 10.1.0.0/16. Now let's go ahead and create NAT gateway. My NAT gateway 1, and we are going to select the public subnet on availability zone 1. So the NAT gateway will reside in the public subnet in the availability zone 1. And currently we don't have any elastic IP address. Let's go ahead and allocate an elastic IP address and create the NAT gateway. This would take a while. Once this is created, we can go ahead and add the route on the private route table 1 for our EC2 instance that we are going to create on the private subnet for package updates. So the EC2 instance on the private subnet will use the NAT gateway that resides in the public subnet 1 for any package updates to reach the internet. Now let's go to RDS. And start creating our database engine. I'm on that RDS dashboard and click on databases. I don't have any database created right now, and before creating the database we need to create the subnet groups. This is the subnet groups will be used when we create the database engine. So we have already created 2 subnets for our database layer. So the private subnets 5 and 6, so we can use that here. Let's create the DB subnet group. I'll just name it my subnet group. Use the same as the description. Select VPC 1, and then we need to add this availability zones. So since we are going to create the database engine as a high availability one with a multi-AZ, so let's go ahead and select both US East 1A and US East 1B, and select the subnets on US East 1A and 1B. If you remember, the subnet with a CIDR range 10.150/24 and 10.160/24 are the ones that we created for the database layer 3. So let's go and use these two private subnets and create the subnet group. It's created. Let's go to databases, create the database. Let's go ahead and use the standard create, and by default Amazon Aurora is selected. Let's go ahead and select MySQL for this video, and let's select MySQL 5731. And we are not going to use this for protection, so let's go ahead and select dev test, and database identifier, we can just name it MySQL DB1. For the credentials, let's use admin. I'm not going to change the username here. Give the password. Give the password here. And DB size, let's use standard classes. And let me just go ahead and use DBM file large. That's good enough. And storage, I'm just going to use 20 gig general purpose SSD. It's perfectly fine. Auto scaling, for this lecture I'm going to disable in auto scaling the storage. And for the multi-AZ deployment, I'm just going to say yes. Say create a standby instance. And for the VPC, select VPC 1, and by default our subnet group that we created has been selected here. And for the public access, I'll say no, so we are not going to get any public IP address. Anyway, we are going to create the database in the private subnets, which doesn't have any connectivity to the internet. And let's create a new security group. Let's name it as MySQL security group. And the port is 3306. I'm not going to change it. And for the authentication, I'm going to use password and IAM database authentication. And for the additional configuration, for this lecture I don't need automatic backups. I'm just going to disable this one. On encryption, I'm going to leave it. Let the database be encrypted. It will be encrypted using AWS RDS. Master key. I'm going to disable the enhanced monitoring and performance insights. And we are going to create this role by default, and we are going to leave it as it is, like enable auto miner version upgrade. And I don't have any preference window, so I'm just saying no preference. and I'm not going to set any enable the deletion protection. So estimated monthly cost is $254, but I'm just going to delete the instance after the lecture, so that's fine. Let's just review once and check everything is fine. MySQL and MySQL 5731 version, dev test and database identifier, the username and password, instance size, it's good, storage, it's good, no storage auto scaling. We're creating a standby instance and we are using VPC 1 and our subnet group and no public access, and we are creating a security group, new security group, and port is fine, and we are using password and IAM database authentication, and we are enabling encryption. We have disabled the enhanced monitoring. Everything looks good. Let's go ahead and create the database. Okay, so this is going to take a while. In the meantime, let's go and see if our NAT gateway is created. So let's refresh. It's available. Now it is created. Let's go to the route table. Let's select the private route table 1 and edit the routes. Let's add the route. Let's select NAT gateway. So any outbound connection to the internet for the instances that are on the application services layer, it will use the NAT gateway. NAT gateway is highly available in that particular availability zone, but since we are going to create only one private instance, EC2 instance on the AZ1, so one NAT gateway is fine. But if we are going to create the EC2 instances in auto scaling, and if we are having it in multi AZs, so then we need to create the NAT gateway in each availability zone. So this looks good now. And let's go ahead and create EC2 instances in the meantime, so we can use the EC2 instances to connect to the database engine. So I'm going to go to EC2. Let's open EC2 in the new window. EC2 management console. Let's go to instances. Currently I don't have any instances. Let me launch instance. I'm just going to select Amazon Linux to AMI, T2 medium, that's good enough. Number of instances 1. I'm going to create the first instance on the public subnet with a public IP address. Select VPC 1 subnet. Let's select public subnet availability zone 1, use East 1A, and the auto assign IP address, let's enable. So we are going to get an public IP address for this instance, so we can connect it to this instance from the internet. And I'm going to leave everything else as a default and go to next, add storage. I'm going to add 20 gig, good enough. I'm not going to add tag, and I'm just going to create a new security group. Let me name it as public security group. I'll name it public EC2 security group. I'm just going to use the same as the description here, and I'm going to have SSH on port 22. I'm going to use default. This is wide open. This is not recommended, and maybe let's do my IP. Yeah, let's do it, and then review and launch. Launch, and I'm going to create a new key pair. New key pair. Need to download the key pair. It's done. So I'm going to launch the instance. While this instance is being created, let's go and create one more instance on the private subnet for the application services layer without any public IP address. Select, I'm going to select T2 medium and create one instance, VPC1, and I'm going to select private subnet 1 AZ1, and by default anyway it's a disabled subnet. Anyway, this instance doesn't have any access to the internet. Auto and public setting is disabled. Go next. I'm going to create 20 gig for the storage. No tags. I'm going to create a new security group. Let me name it private EC2 security group. And for this one, let's open all traffic from the security group that is associated with the public EC2 instance. For that, we can select custom and select the security group. Here we can select public EC2 security group. Since this instance is going to be in the private subnet and without any public IP address, we cannot access this instance directly. So we are going to use the instance that we have already created on the public subnet, the public EC2 instance, as the jump host or the bastion host. First we will log into that instance via SSH, and then from the public EC2 instance we can access the EC2 instance in the private subnet. Since this is in the private subnet, this one can only be accessed from the public EC2 instance. I'm allowing all the traffic from the security group that is associated with that instance. Now let's go ahead and launch it, and I'm going to select the key pair that I have already created, acknowledge, and launch instance. So it's going to take a while for the instance to be created. First instance is already created and it has a public IPv4 address, and the private EC2 instance is being created right now. Let's go and see if the RDS database is created. So it's still getting created. It would take a while. So let me go ahead and pause this video and come back once the RDS instance is created. Then we'll continue. Hey, our database instance is now created. Let's check. Status says it's available. And multi-AZ, yes. Let's click on the database identifier. It's available. DBM5 large instance. Here, the endpoint is this one. So let's first go ahead and see if our EC2 instance is created. Yep, both our EC2 instance is created now. And let's go ahead and connect to the public EC2 instance. Click on connect. I'm going to connect using putty. I have already created ppk file from .pem file. And let's connect using ec2-user at the public IP address for public EC2 instance. Yep, it just moved to the other window. Okay. Now we have connected to the public EC2 instance and using putty session. If you see 10.1.1.2.2.3, that's the private IP address for the public EC2 instance. Now let's SSH to the private EC2 instance from the public EC2 instance. I have already enabled that SSH forwarding, so I don't need to copy the .pem or ppk file to this instance, so the authentication happens on the local machine. Let me see SSH. Yep, 10.1.3.54. We have now connected to the private EC2 instance from the public EC2 instance, that is from the jump box or the bastion host. Let's change to root user and let install MySQL client. So this would work because we have already created a NAT gateway on the public subnet where that EC2 public EC2 instance is there, the same subnet is the public subnet 1 on availability zone 1, and then we have edited the routing table to use the NAT gateway for outgoing internet connection for the instance that is on the application layer. Yep, it works. It's completed. Now let's see if we can connect to our database engine. Let's go to DB and copy the endpoint. Host -p, that is for port 3306, and user admin -p for password. If you hit enter, it will prompt you for the password. Let's go ahead and type in the password that we have used when we created the DB instance. Now this is not going to work. The reason, we haven't added the permission on the updated the security group to use the incoming connections from the private EC2 instance. Let's go ahead and take care of it. Let's go to EC2. Let's go to security group and select MySQL security group. Click on the inbound rule. It just has MySQL Aurora connection on the port 3306 from my IP address. Now let's go ahead and edit inbound rule. I don't need it to be able to, I don't need to access this from my instance. I can delete it because anyway this instance doesn't have any public IP address. So what I'm going to use, I'm going to select all traffic from the security group, the private EC2 instance. So you see private EC2-SG security group, So if we select, because we are allowing the input inbound connection only from the instances that is on the private subnet. So let's go and select private EC2 security group, and let's go and add one more rule and select all traffic again, and let's self-reference the security group for the SQL instance. So let's select MySQL security group. So this has all traffic. So any instances that is within the MySQL security group will have full connection. This is good now. Okay, we have updated the security group. Let's go back to, yeah, let's try connecting to the SQL database engine. Now it is connected. Let's go ahead and create a database, sample database. Yep, it's created, and let's select this database, and this doesn't have any tables at the moment. And let's go ahead and create table. Now we have one table, that is products, and if you want to see, so this is the products table that we have created. Now let's go ahead and insert some value. And let's query the database. Yep, it works. So this is how it is easy to create MySQL RDS database engine using custom VPC on the private subnets. Hope you would have find this video useful. Thank you.